Hello friends, welcome back to my channel, myself Chirag. In this video, I am going to discuss about SSH, topic of network security. Let's check the outline of this video. First topic is introduction of SSH, in which I have covered what is SSH, and the next one is purpose of SSH. Another topic is SSH Protocol Stack. Before start this video, subscribe my channel. Follow my blog chiragbhalodia.com. All the video materials are available in my blog. Let's start with the first topic, introduction of SSH. SSH stands for Secure Shell. Next, what is SSH? SSH is a protocol for secure network communication. It is designed to be simple and inexpensive to implement. Next, purpose of SSH. SSH provides secure remote login facility to replace telnet and other non-secure remote login schemes. Next, SSH also provides a client-server capability and can be used for the search network function like file transfer and email. So it means using the SSH you can access any remote PC securely. Next topic is SSH Protocol Stack. SSH uses combination of three protocols that typically run on the transport layer. First protocol is SSH User Authentication Protocol. Name suggests itself, this protocol is used for the authentication. So it is responsible for authenticates client to the server. Next protocol is SSH Connection Protocol. It is responsible to create encrypted tunnel into several logical channels. And the third protocol is SSH Transport Layer Protocol. It is responsible for server authentication, data confidentiality, data integrity, and data compression. Let's discuss all the protocols one by one in detail. Let's start with the SSH Transport Layer Protocol. SSH Transport Layer Protocol focus on main three functions. The first one is host keys, second one is packet exchange, and the third one is key generation. Let's discuss all these three functions one by one in detail. Let's start with the host keys. Server authentication occurs at the transport layer based on the server possessing a public or private key pair. A server may have multiple host keys using multiple different asymmetric encryption algorithms. Multiple hosts may share the same host keys, and some of the hosts have different host keys. Server host key is used during key exchange to authenticate the identifier of host. For this to possible, client must know about server's public host key. For the key exchange, two alternative trust model that can be used. In first model, the client has a local database. All the clients are connected with this local database. Local database stored each host name with the corresponding public host keys. This method has no required administrative infrastructure and no third-party coordination. So disadvantage of this method is it is very tough to maintain name-to-key association without administration. In second model, the host name to key association is certified by a certificate authority. In this method, the client only knows the CS root key, and then client can verify all the host keys certified by CS. This method is also solved host to key maintenance problem. It is maintained by the certification authority. The another advantage of this method is only a single CS root key needs to be securely stored on the client. In this method, each host key must be appropriately certified by a central authority before authorization is possible. So this is all about host keys in SSH Transport Layer Protocol. Next function is packet exchange. Let's take one scenario to understand the packet exchange. For example, there is one client and there is one server. First, client established a TCP connection to the server. This is done by the TCP protocol and it is not a part of the SSH Transport Layer Protocol. Once the connection is established between the client and server, then client and server exchange the data. It is referred to as packet. Now discuss the SSH packet format. For example, this is my data or payload. Now apply compression algorithm to the data and compress the data. After compression of data, padding is added. Here, purpose of the padding is that make a fixed size block of data. After that, padding length is included. Then after, whole packet length is included. So this is my unencrypted packet. Now sequence number is given to the unencrypted packet. After that, encryption algorithm is applied to the packet and encrypt the packet. After that, MAC algorithm is applied and generate a MAC and attach with the ciphertext block. So this is called as SSH packet. SSH Transport Layer Packet Exchange consists of a sequence of steps. The first step is identification of string exchange. It begins with the client sending a packet with an identification string to the server. This message consists of the SSH version and software version which is used at the client side. It also includes the special character, then comment section, it is optional. Then next is CR, it means the carries return, and the last one is line feed. Let's see the example of this message. It is SSH 2.0, so it is SSH protocol version. Then software version is builds SSH 3.6.3. Then after special character, carries return and line feed. After client message, server responds with its own identification string. These strings is used in Diffie-Hellman key exchange algorithm. Next step is algorithm negotiation. In this step, client and server send an SSH message key exchange initialization. This message contains a list of supported algorithms. There is one list of each type of cryptographic algorithm. The first one is key exchange algorithm. Here, Diffie-Hellman key exchange algorithm is used. The next category is encryption algorithm. Now see in this table, these are the encryption algorithm which is used by the client and server. And then after MAC algorithm which are used by the client and server. And the last category is the compression algorithm which is used by the client and server during the communication. Next step is SSH key exchange. Here Diffie-Hellman algorithm is used for the key exchange. The following steps are involved in key exchange. First of all, values P, G and Q are known to both client and server. These values are exchanged during the algorithm negotiation step. Here P means the large prime number, G indicates a generator for the subgroup, and Q is the order of the subgroup. Next value is K underscore S. It is server's public host key which is shared with the client. Now calculate master key at the client and server side using the Diffie-Hellman key exchange algorithm. So at the client side, the first value is V underscore C is client's identification string which is shared in the second step, identification of string exchange. At the server side, the value is V underscore S. It is server's identification string. Next value at the client side is I underscore C. It indicates client's SSH message key exchange initialization. It is shared between the algorithm negotiation step. Next value at the server side is I underscore S, which is same as the I underscore C. It is also exchanged during the algorithm negotiation step. So here all the values are exchanged during the step number 2 and step number 3. Now client will select random value X and calculate E is equal to G raised to X mod P and share the value E with the server. Now at server side, server will select random value Y and then calculate value F is equal to G raised to Y mod P. After that, server will calculate secret key K. Here K is equal to E raised to Y mod P. Value E is shared by the client to the server. Now server will generate hash function and also generate one sign and include in the hash function and send to the client side. Now client get the value F from the server side. After that, client will generate a secret key K is equal to F raised to X mod P. Now client will decrypt that signature and match with the hash function for the authentication purpose. So after a result of this step, client and server share a master key K with each other. Here hash value H serves as a session identifier for this connection. Next step is end of key exchange. The end of key exchange is signaled by the exchange of SSH message new keys packets. At this point, both sides may start using the keys generated from the master key K. Now the final step of the packet exchange is service request. In this step, client sends a service request either the user authentication or the connection protocol. After that, all the data is exchanged, which is protected by the encryption and MAC. Next function is key generation. The keys used for encryption, MAC and initial vector are generated from the secret key K. So now the key generation values are calculated as follows. So here the first key generation value initial vector from client to server. Here in this hash value K is the secret key, H is the hash value from the key exchange and the value A is generated key from the secret key K, and session ID indicates the session identifier. Here session identifier is equal to hash value unless there has been a subsequent key exchange after the initial key exchange. The next key generation is initial vector from server to client. So here generated key is B from the secret key. Next generated key is encryption key from client to server. So here value C is generated from the secret key K. Next key generation for encryption key from server to client. Here value D is generated from the secret key K. Next generated key is integrity key from client to server. Here value E is generated from the secret key K. and the last generated key is integrity key from server to client. Here value F is generated from the secret key K. So this is all about key generation for SSH Transport Layer Protocol. Next protocol is SSH User Authentication Protocol. This protocol is focused on main three functions. The first one is message types and formats. Second function is message exchange. And the third function is authentication methods. Let's discuss the first function, message types and formats. There are three types of messages are always used in the user authentication protocol. From these three types of message, first message is used by the client side. The message is user authentication request. This message is sent by the client to the server. This message is include following things. The first one is username, the second one is service name, and the third one is method name. Here username indicates the authorization identity of the client. The next is service name. Service name is the facility to which the client is requesting access from the server. And the third one is method name. It indicates the authentication method being used in the request message. Here in this message, value 50 is indicates the client request message. After client request message, if the server accepts the authentication, it sends a single byte message. This message is user authentication successful. Here in this message, the value 52 indicates the user authentication is successful at the server side. Another possibility is that if the server rejects the authentication request, then server sends a message user authentication failure to the client. This message includes the name list. It requires one or more authentication method. And another value is boolean. It shows the partial success authentication. So in this function, these three types of messages are always used in SSH User Authentication Protocol. The next function is message exchange. Let's take one scenario to understand the message exchange function. For example, there is one client and there is one server. Now message exchange takes place between the client and server. It includes the following steps. Step number 1 is client send user authentication request to the server. After client's authentication request, server check the username. If username is invalid, the server send authentication failure message to the client. If user authentication is failure, then server send a list of authentication method to the client. After that, client select one of the method from the list and again send a request to the server. After that, server check the authentication request. If more authentication required, then server send partial success value true to the client. When all required authentication methods succeed, then server send user authentication success message to the client. Next function is authentication methods. The server require one or more of the authentication method from the following list. The first method is based on the public key, the second one is host based, and the third one is password. Let's discuss all these three methods one by one in detail. Let's start with the first method, public key. For example, there is one client. Client want to access a services from the server. Before access the service, client prove its authentication. So first of all, client will prepare one message. This message is encrypted using the client's private key and also appended client's public key with this message and send this message to the server side. Server will accept that encrypted message and find client's public key and then apply client's public key to that encrypted message and decrypt that message. So it means authentication is successful at the server side. So now client can access the services from the server. Next authentication method is host based. For example, all the clients are connected with the central system. It is called as host. Host public key is shared with all the clients. Host private key is remain private because it is known by only host. Now client A want to access the services from the server. So client A send a request. But server will not communicate with client A without authentication. To authenticate client request, server will communicate with host. And also server has host public key. Now host will prepare one message. It is encrypted by host private key and sent to the server. Server will accept that message and apply host public key and decrypt that message. So now authentication is successful. So now server and client can communicate with each other. Next authentication method is password. In this method, client send a message containing a plain text password. And this method is encrypted by the Transport Layer Protocol. So this method is the simplest method of the authentication. So this is all about authentication methods. Next protocol is SSH Connection Protocol. SSH Connection Protocol runs on the top of the SSH Transport Layer Protocol. And it assumes that secure authentication connection is in use. Here, secured authentication connection referred to as a tunnel, which is used by the client protocol to multiplex a number of logical channels. SSH Connection Protocol focus on the three main functions. The first one is channel mechanism, the second one is channel types, and the third one is port forwarding. Let's start with the first function, channel mechanism. All types of communication using SSH are supported using separate channel. In this function, for each channel, each side associates a unique channel number, which need not to be the same on both ends. So it means channel number from the client side and the server side, both are unique. Next, the life of a channel progress in three stages. The first one is opening a channel, the second one is data transfer, and the third one is closing a channel. Let's discuss all these three stages one by one in detail. Let's start with the first stage, opening a channel. Let's take one scenario to understand the channel mechanism. For example, there is one client and there is one server. Now, client want to communicate with the server. So first of all, client establish a connection with server. So this connection is already established by the Transport Layer Protocol. After establishment of connection, client want to open a new channel with server. So now client send one message to the server to open a new channel. This message includes the following things. The first one is channel type. The second one is sender channel. Third one is initial window size. And the fourth one is maximum packet size. Here in this message, the first element is channel type. We will discuss channel type in next function. The second element is sender channel. It indicates the local channel number. It is given by the client. Next element is initial window size. It indicates how many bytes of channel data can be sent to the sender of this message without adjusting window size. And the last element is maximum packet size. It indicates the maximum size of an individual data packet. In this message format, in last three elements, it shows UINT32. It means unsigned 32-bit integer. After receiving a request of the client to open a new channel, if server is unable to open a channel, then server sends a failure message with a reason code indicating the reason of failure. Another possibility is that if server is able to open a channel after receiving a request of the client, server sends a confirmation message to the client. It also includes sender channel number, receiver channel number, window size, and packet size. Once a channel is open, then the next phase is data transfer. After a channel is open, client and server exchange the data using SSH message channel data. This message includes the receiver channel number and the block of data. After completion of data transfer, the next phase is close a channel. When either side wishes to close a channel, it sends a close message. It includes the receiver channel number only. So this is all about channel mechanism. Next function is channel types. There are four types of channel recognized in SSH Connection Protocol. The first channel type is session. This channel is mostly used in remote execution of a program. A real-time application of this channel is file transfer, email, system command, or some built-in system. Once channel is open, subsequent requests are used to start the program. Next channel type is X11. This kind of SSH channel is used in X Windows system. This channel provides graphical user interface for the network computer. So it means application run on a server but to be displayed on desktop machine. So this kind of channel mostly used in distributed network environment. Next channel type is forwarded TCP/IP. It refers as a remote port forwarding. And the last type of channel is direct TCP/IP. It refers as local port forwarding. So here last two types of channel, remote port forwarding and local port forwarding, will discuss in next topic. So this is all about channel types of the SSH connection protocol. Next function is port forwarding. Port forwarding is the most useful features of SSH. Here there is one question, what is port? Port is an identifier of a TCP user. Let's take one scenario to understand the port forwarding. There is one client and there is one server. Here client and server wants to communicate with each other. For example, at the client side, there is one application. It is identified by the port number X. And same as the server side, there is one server application. It is identified by the port number Y. Now client application invokes a local TCP entity. Client side local TCP entity send a request for a connection to the remote server on port Y. So it means local TCP entity negotiate a TCP connection with the remote TCP entity such that the connection links local port X to remote port Y. But this connection is unsecure TCP connection. To secure this connection so that SSH Transport Layer Protocol establishes a TCP connection between the SSH client and SSH server entities with the TCP port number A and B. So now we can say a secure SSH tunnel is established over this TCP connection at port number X and Y. So traffic from the client at port X is redirected to the local SSH entity. Then after this traffic traveled from the SSH tunnel and reached at the remote SSH entity. After that, remote SSH entity delivers this data to the server application on port number Y. So now we can say this is the connection via SSH tunnel. So connection using the SSH tunnel is secure connection. Next, port forwarding ability to convert any TCP insecure connection to a secure SSH connection. Here secure SSH connection means the SSH tunneling. SSH tunnel is always created between the local SSH entity and the remote SSH entity. Next, SSH supports two types of port forwarding. The first one is local port forwarding and the second one is remote port forwarding. Let's discuss both the technique one by one in detail. Let's start with the first technique, local port forwarding. Let's take one scenario to understand the local port forwarding. For example, there is one client and there is one server. Here we are discussing about how email can be accessed from mail server to desktop client. For example, there is one SSH client at the client side. First of all, SSH client set up a connection to the remote server. Now SSH client select unused local port number 9999 at the client side and configure it to accept traffic from this port. Now SSH client inform the SSH server to create a connection to the destination mail server at port number 110. Why it is port number 110 at server side? Because POP3 protocol is used at the server side. So now here SSH tunnel is created between the client and server. So now client will send the data from unused port 9999 to SSH client. SSH client will encrypt that data. Now SSH client send this data to SSH server through the tunnel. After receiving encrypted data from the SSH client, SSH server will decrypt that data and send to the port number 110. And finally, server receives the data of the client. And the same scenario at the server side. If server wants to transfer a data from server to client, so first of all, server send data to the SSH server from the port number 110 and server will encrypt that data. Then after, SSH server send this data to the SSH client through the tunnel. After receiving an encrypted data from the SSH server, SSH client will decrypt that data and send to the unused port 9999. And finally, client will receive that data from the unused port 9999. So this is all about local port forwarding in SSH Connection Protocol. Next technique is remote port forwarding. Let's discuss one example to understand the remote port forwarding. If you wish to access a server at work from your home computer, but work server is behind a firewall, so it will not accept any SSH request from your home PC. So here you have to use the remote port forwarding technique. In previous technique, we have set up an SSH connection from the client side. Here in this method, home PC is a client. But in this method, we have to set up an SSH connection from the server side. So now, from the work computer, set up an SSH connection to your home computer. We all know that the firewall will allow this connection because it is protected outgoing connection. Now configure SSH server to local port number 22 at server side. Now SSH home computer select one unused port 2222 and configure this port with SSH home computer. So now SSH tunnel has been created between the SSH home computer and SSH work computer. It can be used for the remote logon to the work server. Now check how can you access the data from work server to your home PC. Whenever you access data from your home PC to work server, server will send that data to SSH work computer from port number 22. SSH work computer encrypt that data and send to the SSH home computer through the tunnel. SSH home computer receive that data and decrypt that data. And then SSH home computer send this data to port number 2222 to your home PC. So this is all about remote port forwarding. Now check the SSH Protocol Summary. First of all, we have discussed SSH Transport Layer Protocol. In this protocol, I have discussed host keys, packet exchange, and key generation. Then after, we have discussed SSH User Authentication Protocol, in which I have discussed message types and formats, message exchange, and authentication methods. And then discussed last protocol, SSH Connection Protocol. In this protocol, I have discussed channel mechanism, channel types, and port forwarding. If you have any query, you can join my Telegram group Chirag Bhalodia. Link is given in description. Follow my blog chiragbhalodia.com. All the video materials are available in my blog. If you like this video, please hit the like button and share with others. Don't forget to subscribe my channel. Follow me on social media. All the links are given in description. Thank you for watching this video.